In this video we illustrate a traditional use of statistical clustering, which is to find clusters of attributes or questions in a questionnaire that belong together because they correlate highly. The file again comes from the book from Andy Field. He had a questionnaire with 23 questions, Q1 to Q23, and over 2,500 subjects filling in this questionnaire. And so the issue is finding which questions correlate highly, belong together. So we've read the data into ILLMO. So there's 23 attributes, and we look at the overview page. And one of the options being offered is the option to create patterns from observations, so which is the same as clustering. So one of the first we do traditional clustering, which is actually 1D clustering, and the relevant parameter is the minimum eigenvalue, which we set to 1 in this case, and after which we can run the clustering. So we find that there are 4 clusters and that each attribute is assigned to a cluster, as shown in this text file that was produced on my second screen. See, the first question goes to cluster 4, the second question to cluster 2, and again, so this is graphically represented. And we could also look at the squared correlation for each of the questions with their cluster average, which is, so there are 4 patterns that actually summarize the 23 questions, and each of them is assigned to them. This text file also tells you which question is assigned to each cluster, and also gives indication of how good this cluster is. So Cronbach's alpha above 0.8 is actually quite good. So for 3 of the clusters, the clustering is very good, but for cluster 2, it is much less so. So this is probably what it means is that probably still some differences between these questions. Now we can influence the clustering by changing the minimum eigenvalue. For instance, if we increase it to 1.2 and run the algorithm again. We find that there's only 2 clusters now, and you can also look at the squared correlation, and they will typically be lower because it's more difficult to assign 23 questions to 2 clusters than it is to assign them to 4 clusters. This doesn't show much relationship, so there's another way to actually perform clustering that shows more relationship between the different questions. That's to perform what I call 2D clustering, so in which we make clusters where the underlying pattern is not one-dimensional but two-dimensional. So in this case there's only 1 cluster, and so every question will be characterized by 2 numbers, actually the regression coefficients. And we see again that there are largely 2 large clusters of questions that belong together.